All right, so the last in the series of quick videos on derivatives of functions, according to the formal definition and the alternative definition, is one about radical equations or irrational equations. So let's take a look at the alternative version first. So suppose that I had a simple equation, f of x is the square root of x plus 6, and I kind of picked this on purpose. At x equals 10, some random value. So if I plugged in x is 10, I think we get the answer of 4, right? So that means somewhere out on the graph at 10, I would like to know what is the slope at 10 comma 4. Now, according to that alternate definition of derivative, I would take the limit as x approaches 10 of f of x minus f of 10 all over x minus 10. Now, in this case, you might feel like that didn't really do that much to help me out, but it's actually quite a lot easier problem than dealing with the h version. So we'll see what happens. So I got x plus 6, that's f of x, minus f of 10, which we know to be exactly 4, over x minus 10. Now, in this particular story, I would like this original denominator to go away. So what I'm going to do is I'm actually going to do the opposite of what we would normally do, and I'm going to actually multiply by the conjugate of the numerator. So I'm going to do a root x plus 6 with a plus 4. I'm going to go ahead and leave the denominator unchanged because what I'm hoping is that this original x minus 10 that is sitting there is going to go away. And so let's just leave this stuff right here as it is. And now notice if we start distributing, root x plus 6 times root x plus 6 is x plus 6. When we distribute, the 4 roots and the negative 4 of those roots would actually cancel out. That's why I use that conjugate, and negative 4 times 4 is negative 16. Well, what do you know? Something really nice happened because this numerator just became x minus 10. And remember, my whole goal was this x minus 10 in the denominator to go away. So it appears to me that it in fact did happen. So as x gets really, really super close to the number 10, I would get 1 on top, and this one would be root 16, which is 4, plus 4, which is 8. So that was actually not that bad of a question using the alternative definition of a derivative. But again, the downside is this would only tell me the slope of the graph at specifically x equals 10. So I'm going to go ahead and do a quick share to Desmos so we can kind of see what actually happened there. Let's go over here and share with Desmos. I have my equation here. I have 10 comma 4 sitting right there. And so if I use the point slope form of a line, there's my nice little point slope form of a line. And when I did that, I found that my slope at that value should have been 1/8. So I'm going to put a 1/8 right there. And what we see is the graph just barely glances the curve at 10 kind of 4. They match up really, really nicely. And we kind of confirmed our results. Now, if we wanted to go with the other version, which is a much stronger version, we could actually validate that we have that same slope. And so let's go ahead and take a look at that with root x plus 6. So this is the formal definition. So again, if f of x is root x plus 6, let's take a look at the limit as h goes to 0. We're going to do f of x plus h minus f of x all over h as h goes to 0. Now, don't forget, we're really hoping this original denominator is going to go away, so I'm going to use the conjugate of the numerator, because the numerator is actually this time, I'm hoping I can do something good to make the numerator have an h in it so that I can make the original denominator go away. So in that previous problem, it was actually a little hard to do the numerator. This one is actually designed to be sort of nice because when you distribute, The outer and the inner term, see, this term and this term are complete opposites. That's why we did the conjugate. So you have x plus h plus 6 from this first chunk, and then you have a minus an x plus 6 from the back chunk. And remember, we said we're not even going to deal with the denominator. We're just going to let it hang and hope that it gets better. Now, what happened that's kind of nice is I've got an x here and a negative x here. I've got a positive 6 and a negative 6. Well, that's crazy. The only thing left in the numerator is h. So all I have left on top is an h, and the bottom has all this other stuff in it, so I know that those would cancel out. So it looks to me like all that I have left is the limit as h goes to 0. Remember, all of the h's went away, and I have root x plus h plus 6 and another root x plus 6. Well, this surprises people a little bit, because when you look at it this way, as h goes to 0, this is root x plus 6 plus another root x plus 6. So we have two of those root x plus 6s. They actually just double up. And so since my original function was called f, then I could say f prime of x is that. Now, if we were to go back to the earlier way that I did this problem, I said, hey, what is the slope at 10? Well, let's see. If I plugged in 10, I'd have 2, and I'd have the square root of 16. Square root of 16, of course, is 4, and I got 1 over 2 times 4, which is 8. So even though I did it in a very different way, I got exactly the same answer from that problem as I did the other direction. So that's a quick example of a radical or an irrational based equation. I hope that that was helpful, and we'll pick